Hi everyone, it's Dennis Gravett here with just one question for you today. What are clouds made of? Yeah, and what does this have to do with chemistry? Well, in the last video, we talked about three states of matter, right? So let's zoom out. Ooh, wrong way. So there's the gas phase, the liquid phase, and the solid phase, three states of matter, right? And water can exist as solid, liquid, and gas too, right? Ice, liquid, water, steam. So my question for you is, what makes up the clouds? What are clouds made of? And the answer I'm looking for is not, hey, it's made of water. Yeah, that's a given. But the water that form clouds, is that a gas, a liquid, or a solid? I think for me, the key is to figure out, well, what's helpful, is figure out what we mean by steam. What do we mean by a gas? Because, hey, it looks like these teapots are producing little bits of clouds here. I guess in a sense they are. Let's zoom in on, oh, this bottom tea kettle here might work well. Try again. There we go. Oh, that's not so bad. Let's go on the other one. There we go. Okay, so got this hot tea kettle full of boiling water. And my question now, I guess I got a second question. Where's the steam? And as I look at this, I'm thinking steam. Well, let me ask you another question. Where would you like to put your hand over this tea kettle? If I had to stick my hand over the tea kettle, I would put my hand up here and not right here near the spout. Why is that? Because it's hottest down here, right? Right? So up here, this material that looks like a cloud is cooler than this area over the exit of the tea kettle. This is hotter. And this is invisible. What's going on there? Yeah, so, you know, in the teapot, tea kettle, there's hot water boiling. What is boiling? It's liquid water changing to a gas. Right? I shouldn't say liquid water, right? Lots of things can boil. We're talking about water though. Yeah, liquid water turned into steam. And that steam is a gas which comes out of the spout. So right here is the steam. And you don't see anything, right? One of our definitions of a gas is individual gas molecules that are unstuck to each other, right? So back here when we talked about states of matter, we said liquids are where the little individual molecules are sticking together and bouncing around. The gas molecules are moving so fast they can't stay stuck together, and they exist as individual molecules that are too tiny to see. Can't see them, they're too small. That's a gas. That's what we have exiting the port of this kettle. Oh, where'd it go? Here somewhere. There it is. Coming out of the tea kettle right here. I don't see anything, but you know it's there. If you put your finger in it, you would get a burn because the steam is really, really hot. These water molecules coming out here are moving so fast, they can't stay stuck together. They're individual gas molecules that we cannot see. It's only after these gas molecules come out and start bumping with the air out here, the air is cooler and it starts slowing down the steam, slowing down the gas molecules, water molecules. And now as they slow down, cool off, they do start to stick together. And what we have here are tiny liquid droplets of water. Lots of water molecules stuck together that are now big enough that they can scatter light, and now we can see them. Oh, where'd it go? Let's zoom back in. There we go. So here we go. Here's a little sketch I found on the web describing the sizes of raindrops. These little tiny dots are called condensation nuclei. Yeah, chemists, scientists love terms for every new idea. Down here, we got a huge water droplet, right? So it's so big. At this scale, you can't even show the whole drop. It's so big. This water droplet is heavy enough to fall to the earth, fall as a raindrop. But these little ones, especially these super tiny ones in here, those keep bouncing around in the air. They're not heavy enough to fall to the ground. Updrafts, keep pushing them up. In the air, water still evaporates, right? You throw some water on a hot sidewalk, water will evaporate. It doesn't have to boil to turn from liquid to gas. It evaporates, and that's what can happen here. These little droplets can lose water as liquid water changes to gas, so they can shrink. Then the gaseous water can start sticking to these other little droplets and make them grow. Humidity, gaseous water molecules sticking together, start clumping, forming bigger droplets. And if they grow big enough so that they can fall, then we get rain. If they don't, then you just get these white poofy clouds. So hey, what are clouds made of? Liquid water, or maybe solid water, but not gaseous water. I mean, gaseous water is there. You can't see it. So what are we looking at here? Up here, we're looking at either liquid or solid water. Isn't that crazy? Here's another idea. Whoops. Down here we have a cloud on the ground. You know that is fog. So next time it's foggy outside, realize that's actually just a cloud on the ground. Go walk outside and have some fun in that cloud. And convince yourself they're just tiny, tiny little water molecules, mist, little misty water. Get a little spritzer, spray some water in the air, you get little tiny droplets of water. Some have enough to fall, but other little tiny droplets can still float in the air. Those little tiny droplets of water make up the clouds. And if they freeze, that would be hail. If they crystallize, that will be snow. Solid forms of water. Okay, that's enough for now. Thank you.